So when we have a single categorical variable, we want to look at a few ways that we can display it in a graph, and then how we can calculate values from this categorical data. So what we're going to do here is use a categorical variable where they collected eye color. So this is the actual variable that was collected, and then we have these possible answers where the people in the group either answered blue, brown, green, or other for eye color. And what we have next to it is the frequency. So what we have here are 5 people said they have blue eyes, 13 have brown eyes, 2 have green, 3 have an other. This right here is called a frequency table. So frequency table combines the categorical variable and all of the possible categories, and then it aligns a frequency, or frequency can also be described as the count for each of those categories. Something else we can do is find the relative frequency, and what this does is it takes these frequencies that we have and translates it into a percentage of the group. So something we're going to need here is our total sample size, and to find that you just add up the frequencies for the group, which there are 23 people. So this right here is our sample size, which in statistics what you'll see for sample size is often we use the symbol n to represent sample size. So to get relative frequency, we're creating a fraction. So we're looking at 5 out of 23 to get this percentage of the group that has blue eyes. And that would translate to 21.74%. And we do this for each of them. So for brown eyes, 13 out of 23, which would be 56.52%, and then 2 out of 23, which would be an 8.7%. And when you take 3 out of 23, that should be a 13.04%. And what should happen if you add up these relative frequencies is you should get 100%. We should be covering 100% of our sample when we lay out all these relative frequencies. Sometimes due to rounding, you might get out 100.01 or 99.99, and those are fine. That's close enough to 100%. It just means we had to round a certain way and it got thrown off a little bit. But if you use the exact numbers, you should be getting 100% out. So these are 2 different types of tables here. We have a frequency table, which is just the categories and the frequencies, and relative frequency table, which is just a combination of those categories and those percentages. For graphs, what we can do is make a bar chart or a pie chart. So the bar chart's going to use the frequency table, and we're going to have here along the y-axis are the frequencies. So those are the counts coming through. And along the x-axis, we're going to have our categories. Now, when we make our bar charts here, we want to create these bins for each of the separate categories. And how we do that is kind of important. What we're going to need to do is start with a little space here between the origin and that first bin. So I draw a little space moving to the right, and then create this bin for blue eyes. And then you're going to have a little bit of space, and then you draw the next bin. And a little bit of space, and we'll have green. And a little bit of space, and we'll have other. So these bars, when we draw them, they shouldn't be touching. We should have a space between each of the bars to show that there are these discrete groups. There isn't any overlap between them. Then we draw the bars to the height of the frequency. So blue group had a frequency of 5, so we draw to a height of 5. And for brown, we had 13, so we want to draw to a height of 13. And for green, we had 2. And other, we had 3. And that's our bar chart. So some key pieces with the formatting of bar charts are the spaces between the bars. And also what you should note is that this could be in any order. If we wrote them in order of green, then blue, then other, then brown, we could have a bar chart that looks different, but as long as you keep the frequencies matching the group, it means the same thing. So with bar charts, we don't examine the shape of it. Instead, all we can talk about is kind of highest frequency, lowest frequency, and how it decreases. But in terms of shape, we can't describe that because it could have any shape. It just depends on what order we put the categories in. Our next form are pie charts. This is great when we're using the percentages, so this uses the relative frequencies. And what we do is we divide up our pie based on these percentages. So I might start with the brown eyes, since that's about half of the circle. It's a little more than half. So I might imagine as cutting this in half, then maybe give it a little bit more, and that would be the group for brown eyes. And what you should do is for each wedge of your pie chart, write the name of the category as well as the percentage. Since they're not being drawn exactly accurately, we need to know what number actually attaches. Then blue eyes, that's about a fifth of a circle, so maybe something like this. So there's blue eyes with 21.74%. And then with the remaining, green should be the smallest, and then other a little bigger. So maybe something like this. So it's just estimating as best you can, using your knowledge of fractions to divide up those percentages. So there's our pie chart. This is great for when we have a lot of data. Like the bar chart can get overwhelming if we have these large frequencies coming through, but to really get an idea of a distribution of an overall sample, a pie chart's a great way to display that with percentages. So we have these ways of displaying our categorical variable. Let's talk about what we can calculate from our categorical variables. And this is where we talk about proportions. We can talk about a proportion of the group fitting a certain category. And as a reminder of our notation for proportions, you want to use P, the little hat, and that's when it's a sample proportion. And then if we just use the value P representing proportion, that tells us it's a population proportion. So typically when we're calculating for data, it's going to be sample data. So because we have sample data here, when we calculate these proportions, we want to use that symbol P hat. So P hat, if we want to know what proportion of the group has blue eyes, proportion relates to percentages, which relates to those relative frequencies. So it's this idea of making our fraction. So what proportion of the group has blue eyes? Well, 5 of them have blue eyes out of the 23, and we got that 0.2174. So for our sentence answer, we'd say 21.74% of the group has blue eyes. Then for the next question, what proportion of the group has brown eyes? Same idea. In the numerator, we have the number of people who have brown eyes, which was 13, out of our sample of 23, which gave us that 0.5652. So we'd say 56.52% of the group has brown eyes. Then for part C, what proportion of the group doesn't have brown eyes? So for this proportion, what we want to do is have in the numerator how many people don't have brown eyes. So what we want to do is combine the groups for blue, green, and other. So we want to take those 5 plus those 2 plus those 3 for our numerator out of all 23. So we have these 10 people that don't have brown eyes out of 23, which would give us a 0.4348. So 43.48% of the group doesn't have brown eyes. Then for our last question here, what proportion of the group has green or blue eyes? So this, we want to know how many fit the group of green or blue. So one or the other. And when we use or in statistics, it means one or the other or both. We don't really have the case of both here. I mean, maybe they're combined in the other group, but since we didn't specifically describe green and blue eyes, we have these two groups that we combine. So you want to take 5 people who have blue eyes plus those 2 that have green out of 23. So we have these 7 people who have green or blue eyes out of our group of 23, and that gives us 0.3043. So 30.43% of the group has green or blue eyes. So this is what we can do when we have a single categorical variable. We can calculate proportions using our frequency table and relative frequencies. We can display it with a bar chart to show the frequencies or a pie chart to show relative frequencies.